Alright, let's start this 9.3 video. It's going to be the part 2, and it's mostly about entropy. I'm going to just touch on enthalpy real quick because it's on this slide, but I'm going to focus on entropy, and it's going to be a real quick video, so I'm hoping to keep this in less than 5 minutes. Alright, we've talked about enthalpy or delta H before. Delta H, which is right here, is equal to the potential energy of the products minus the potential energy of the reactants. And, you can't really see that very well, but you will remember that delta H, when it is a negative, it is an exothermic reaction. And if delta H is positive, it is an endothermic reaction. Okay, so I just wrote it again, but it really is the same thing as what is written right here. Alright, and now we have to talk about something new. That new thing is called entropy, or chaos, or disorder. And it's got a symbol of delta S, okay? And it really just means how messy a system is. And to be nice and simple and succinct about this, we're going to look at two things. We're going to look at the number of molecules and the states of matter. First and foremost, solids are regular geometric pattern. They have the least amount of disorder. Liquids have more disorder, and gases have the most disorder. So if you're looking at, let's say we move that out of the way, we look at H2O solid becoming H2O liquid, which is fusion, right? That's melting. That is going to be an increase in entropy. It's as simple as that. If you have carbon dioxide gas going to carbon dioxide solid, you have a decrease in entropy. Very simple. More chaos, more entropy. Less chaos, less entropy. So that takes care of the phase changes. Now let's look at, the next example would be if we are changing the number of particles. So, this didn't work out very well, did it? But let's draw this down there. Let's say we have sodium chloride, solid, and it becomes sodium ions and chlorine ions. These are aqueous. If we start out with 1 mole, one group of sodium chlorides, and we end up with 1 group of sodium ions and 1 group of chlorine ions, 1 mole of sodium chloride becomes 1 mole of sodium ions and 1 mole of chlorine ions. We went from having 1 mole to having 2 moles. I mean, they're smaller, right, because they're half the size, but we've got 2 groups. An increase in the number of molecules is going to give us an increase in chaos or disorder. So it doesn't matter about the size, it's just the number of particles that we have. So this is an increase, I gotta find a pen, increase in entropy. Really is a very simple concept. And let's say we went from calcium and chlorine, and we got calcium chloride. We started with 1 calcium, we started with 1 chlorine, and we end up with 1 calcium chloride. That's going to be a decrease in entropy because we went from 2 particles, or 2 pieces, 1, 2, to 1 group of calcium chlorides. So it's a decrease in entropy. All right, so that pretty much sums up entropy. The only thing I want to add here, if I can squeeze this down, let's see. Oh, look at me. Systems in nature. Can I, let's see. Systems in nature, okay, natural systems tend to go towards more chaos, okay? And that means they're going to have low energy and high entropy. Listen, if you were left to your own devices, you'd probably sit on the couch all day. That would be low energy. and high entropy, you wouldn't have to clean up after yourself. It would become a very messy situation. So systems in nature, natural systems, tend to go towards being lazy and very messy. Think about your bedrooms, okay? So if you go into your bedroom and you do nothing, you just lay there on the bed like a sack of meat with mittens, now that would be low energy, and if you didn't do anything, it would get very messy very quickly. You would have socks hanging from the ceiling, right? So we've got low energy and high entropy. That's what, if we did nothing, that's what would happen. Okay? All right, so that pretty much sums up entropy. And I reviewed enthalpy, which is delta H, just real quick. And I think we did this in about 6 minutes, so that's good for us.